Thank you, ma'am. Thank you for the introduction. So, I'm Manish. I come from the company Global 3D Labs, and I'm one of the co-founders. I'm in this industry since last 4 years. So, yeah, I am here to talk about 3D printing or let's say additive manufacturing. So the topic will be the overview of additive manufacturing. I'll be taking you through the processes, different processes of additive manufacturing, starting from FDM, SLA, SLS, DMLS. So before starting, I would like to know how many of you are here. I'm definitely sure everyone knows about 3D printing or either heard about 3D printing. So how many of you over here have seen a 3D printers in life? Great, great, great. So before starting the overview of 3D printing, let me tell you a short intro about Global 3D Labs. So Global 3D Labs, we started in the year 2000. Sorry. So Global 3D Labs, we started in the year 2013 in Manipal University. So the story goes like we started with an incubation program with a small grant that we received from Manipal University. The product was called as AiA. So the problem that we were trying to solve was in the dental industry. So right now, if you go to a dentist to get a brace or a bridges or anything to get changed, the overall process might take around 6 to 7 days. Where you go to a dentist, he'll scan and he'll take the negative, and finally a sum of carvings is done and the process goes on. And so what we were planning, and also we somehow managed to do, was by using 3D scanning and 3D printing. So once the 3D scanning of the particular denture is taken, we take the negative of the same part, and after taking that part, we print it with ceramics or let's say dentine powder, and that particular part or a particular brace is replaced over there. Now theoretically this sounded really very easy, but when it came to the practical execution, yeah, it took us some time. There was a lot of constraints since we are right out of the college. So there were a lot of problems that we faced. So that was the reason we got, since we had to run the company, so we started developing 3D printers, which was our bread and butter for the first 1.5 years. So initially we started with Manipal, but again, Manipal is an educational hub, so we couldn't make any sales over there. That's why we transferred from Manipal and we came down to Bangalore, and that's where we started our journey. And I'm proud to say that in last 4 years we are still bootstrapped, though some support from the Indian government, but still we are still bootstrapping. But we have managed to sell around 950 FDM printers till date. We have successfully executed 4 research projects, and currently we have 2 patents filed on the company's name. Other than that, one of the very breakthrough thing that we have done is with the project from Department of Science and Technology for a printer, for a technology called as selective inhibition sintering, which would replace metal 3D printing in future. So that's a very basic concept which is still going on. It's a project for 10 years. And yeah, so that's a short intro about 3D, about Global 3D. I would like to start with the presentation. So Additive Manufacturing India Pvt. Limited is our company's name. We brand our products and the services by the name Global 3D Labs. Currently, we are based out of Hyderabad as well as Bangalore, and we have certain global distributors around. So yeah, so the mission and the vision, let me keep it very simple and let me run it through very fast. So currently there are a lot of 3D printers. If you Google 3D printer, you will get hundreds, thousands of searches. I'm sure eBay, Alibaba, etc., etc. So in today's date, what we are trying to provide is awareness along with the technology. So it is still in its very nascent stage in India right now. But we have seen a linear growth in last 4 years. So when we started, it was nil. It was nothing. There were barely a couple of companies in India who were still striving hard to make it to the market. But in 4 years, today, currently, I can see around 10 successful manufacturing companies in India and around 150 plus service providers in additive manufacturing industry. So we have 3 different wings. First will be the global 3D labs, where we manufacture customized 3D printers. We have different range printers, and we are the pioneers in some range of printers, like the biggest 3D printer in India, that was 1 meter cube, which was already in market, and we supplied it to 2 of the biggest clients. And then we have AMI services, which is a separate wing under global 3D labs, where we take up services and we deliver orders to different clients. AMI R&D, under this wing, we have successfully developed the first PEEK printer. So PEEK will be polyether-ether ketone. So this is the filament that extrudes at 430 degrees Celsius, which is the highest till date. And this PEEK, why we developed only particular PEEK 3D printer is because this will revolutionize the medical market, the orthopedic industry, and also the dental industry. Because the only reason being, currently titanium is the material which is currently running in the market. So PEEK will very soon replace it. Reasons being all of the mechanical and the physical properties. Also cost-wise, it will beat titanium. So this will replace titanium in coming date, for sure. Resin and paste 3D printers. So these are some of the R&D printers that we have provided to a lot of CSIRs. So currently this printer we have installed in CCMB Hyderabad, one of the microbiological institute in Hyderabad. And other than that, we have Praman 1. I'll be showing you the pictures after the technical presentation. So the USPs that we provide is different ranges, quality. Okay, fine, I'm not marketing my products over here. Let us directly start. So when we talk about manufacturing, these are the different types of manufacturing that we currently have in the industry. Talking about casting, molding, forming, joining, subtractive, and additive. So when we talk about additive manufacturing, what we can compare it to is subtractive manufacturing. So what subtractive manufacturing is? Subtractive manufacturing is something where you take a piece of block and then the machine cuts it and then finally makes a product. Which means there's a lot of wastage over there. So this is the traditional method which has been carried forward till the date, and it's still going on. So this is the picture of subtractive manufacturing. In the second picture, you can see a metal part is being fabricated, and this is a nylon part. So why we have compared this is, a lot of people have this thing in mind that only metal can be fabricated. So no, not. It's not like that. Other than metal, there are a lot of plastics, there are a lot of materials which can be fabricated also. Now, comparing this to additive manufacturing, what is the difference? So in additive manufacturing, as you see, it is developed layer by layer. So under additive manufacturing, there are around 12 different technologies, FDM, DMLS, etc. I'll take you through one by one. But anyways, so overall concept of additive manufacturing or 3D printing is a 3-dimensional product is created. So over there you can see, as I said you, there are a lot of wastage over there. In additive manufacturing, the difference will be, there will be no wastage. So what is additive manufacturing? So I've added a GIF over there, you can see. So the GIF shows the FDM process over there. So the spool that you can see is the raw material. That's the polymer coming out of the spool, and it will go to an hot end. It is called as an hot end, where the plastic melts and finally layer by layer any model is created. Now how it is created? So basically I can see a lot of engineers over here, so definitely all are aware about the CAD softwares and all the different softwares that we use to design a 3D model. So once the 3D model is designed, any 3D model can be 3D printed. So that is what I can say is additive manufacturing. Any 3D model, once it is printed, it is sliced layer by layer. So what is slicing? Basically, slicing is you are giving settings. You are giving settings like layer resolution. Infill density is how much dense do you need the part to be. and also the perimeter, number of perimeters. If it needs support structure, then what kind of support structures. So overall, basically any 3D file can be sliced into layer by layer, and it is then converted into G codes and M codes. G codes and M codes is basically the printing instructions. So the machine cannot read any digital file. It can only read certain instructions, which is called as printing instructions. And those instructions are G codes and M codes. So what G codes and M codes are normally, it is coordinates. So basically, the electronics, the microcontroller is telling the printer to move 10 mm in X, 10 mm in Y, 10 mm in Z. So it is instructing. Basically, if you see a G code, once it is sliced, you can see only the numbers, X101, Y101, Z101. It's not a program, it's not a C program, it's not any other platform program. And this G code is automatically generated by the software. There are a lot of open source software, and there are a lot of other softwares too, which convert a 3D digital file to a G code. So 3D printing versus traditional printing. So my experience whenever I go to pitch an FDM 3D printer is to a normal layman. So when I tell them, sir, 3D printer, it is a 3D printer. So a lot of people ask, okay, so where do you put the paper from? And then it is very difficult, it is very difficult to make them understand like the difference between a 2D printer and a 3D printer. So the mentality goes like, okay, even if I add a 3D as a prefix before the printer, but still the thing remains as, okay, fine, printer means I'm putting a paper and I'm getting the printout. So that was the problem that we faced. So this slide, I'm just explaining the difference between a 2D printer and a 3D printer. So in a 2D printer, if you see in an inkjet printer normally, so basically the jetting is happening between a CMYK, the color codes that you give. So basically you are giving the input from the computer, and basically you are getting an output in a 2D format. Now just add a third dimension to it, you can create wonders. So when I talk about 3D printers, the comparison is very simple, but what 3D printers can do is a lot more than a 2D printer. Definitely 2D printer was also when in the early stage, even 2D printers were very quiet for some time, and then today it is available in each and every household. So that is what we are seeing the future of a 3D printer also. In the western side, the 3D printers are getting into each and every household over there. Probably in the coming next 10 to 15 years, we can see a 3D printer stationery or a 3D printer store in every city in India. Yeah. So what a 3D printer can do is, as I told you in the intro, that it's not only the wire, it's not only the plastic that can be printed. Other than plastic, there is food. The houses are created using a 3D printer. There is tissue, the human transplants are being done. It's still at its research stage, but still it has been successful. And other than that, you have metal 3D printing, which is being used by companies like GE, UTC Aerospace, and all the major research companies. Lockheed Martin, all the US research have been, they have gone so far that they are creating robots made out of 3D printed parts. So yeah, this explains how does a 3D printer works.
And toys to clothing and even body. Part of a process known as additive manufacturing, where an object is created by adding material layer by layer. Additive manufacturing allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller, consumer-friendly 3D printers are bringing additive manufacturing to homes and businesses. The first step in 3D printing is to create a blueprint of the object you want to print. You can use modeling software like Blender to create your own designs, or you can visit websites like Thingiverse or Shapeways to find objects other users have 3D modeled. Once you have a finished design, it's time to send it to the printer. Some printers, like the MakerBot Replicator 2, have renewable bioplastic spooled in the back of the device, almost like a string. When the printer receives the data, it pulls the material through a tube, melts it, and deposits it to the plate where it instantly cools. As you can see, the 3D object is created through layering, where the printer will add one layer of the object at a time until you have a fully formed structure. The most common material used in 3D printing is plastic, but the use of some other materials allow for the creation of some pretty amazing products beyond simple tools and toys. 3D printing food is becoming very popular, and additive manufacturing has allowed for the creation of some pretty intricate treats. In the medical world, doctors are testing biomaterials for regenerative medicine. By using a patient's cells, doctors could 3D print small body parts like ears and noses. Some surgeons have even tested 3D printed organs for transplants. Recently, giant 3D printers in China printed 10 houses in just one day and at a cost of less than $5,000 per house, proving just how cost and time-efficient 3D printing can be. For more on 3D printing, check out Mashable's late 3D.
Okay, I think you guys should have got very good idea after this video. So I'm going to explain the different processes under additive manufacturing. So what you just saw was FDM, like the MakerBot printer was printing out of plastic. But I'll tell you the differences basically, so that there's no confusion between all these different technologies. So the application is different, the raw material that is used is different, and the overall process is also different. But the mechanism for all these technologies is the same, which is 3D printing. Basically, there are 3 dimensions, and the head can be interchanged anytime. If I put a normal head, okay, fine, I'll get the plastic. If I replace it with the bio material head, then I'll get a biomaterial product. So we'll start with there are 3 types basically: light polymerized powdered bed and extrusion. So light polymerized is SLA, that is stereolithography assembly, or a DLP. DLP is abbreviated as digital light processing. And then we have powdered bed, which is SLS, selective laser sintering. And then it is extrusion, what you saw in the video, it is called as FDM. It's fused deposition mechanism, or FFF, fused filament fabrication. So let us start with SLA. So okay, so going back to the history of 3D printing. So it is not a new technology, definitely not. So this was even started in 1980s when a person found out accidentally that okay, something like this can be created. But due to a lack of attention and lack of resources, there was no patents filed and there was nothing done at that point of time. But in the year 1986, Mr. Charles Hull, he actually filed a patent on SLA, not even FDM, on a resin-based printer. So after that, in the year 1992, the first patent was filed by the Stratasys company. And it became famous in the 2000s because the patents expired. So patents remain for 20 years, and in the year 2009, all the patents expired for FDM printing, and that's when everyone got into it. In the meanwhile, in the span of these 10 years, there was a forum called as RipRap. So what they did is they opened this forum and made it open source. Now open source is, so if I tell you, you'll be shocked that if I tell you all of you sitting over here can make a 3D printer in your house. Without even going to a 3D printing company or something. Yes, it is true. You can check the forum. It is called as RipRap, R-E-P-R-A-P. So in this forum, how a 3D printer is made from scratch. Each and every detail is given. So that was an open source forum, after which a lot of companies jumped into this industry. And meanwhile, later 2000s, after 2010, what happened is, in the 2013, President Barack Obama also mentioned 3D printing in his Union speech, which also became famous. Meanwhile, in the year 2010, the first liver tissue was also created. In the year 2016, the heart and the kidney transplant was also tried by a company called as Organavo. So all this, this is the brief history of 3D printing. In today's date, as the video showed you, it is not only plastics, but it is more than that. It is building a house, it is printing a kidney or a heart, more than that. So how does SLA work? So basically, if you see, I'll show you a video of this too. So what happens in a SLA is, what you saw in the video was a wire. So instead of the wire, the raw material used in this particular technology is resin. This is a liquid-based technology. So there will be a vat, basically a reservoir, where you put a resin, basically a castable resin or a non-castable resin. The castable resin can be polyurethane or urethane or any epoxy resin. So basically on the top of resin, so as I told you, there are two, DLP and SLA. So the difference is in DLP we use a projector as the source, and in SLA we use a laser of maybe 65 watt power. So in SLA what happens is, there are two approach, it's a top down and a bottom up approach. So in a top down and a bottom up approach means basically the Z axis is moving either from top to bottom or from bottom to up. Instead of the hot end, what we use here is laser. So basically a vat of resin is taken, and on top of that you have the laser module. So wherever the laser moves, that part is solidified, and basically layer by layer the vat goes down or the vat comes up, or maybe the laser moves down. And similarly the part is created, and after the part is created, how you cure it is, you cure it under a UV chamber. Basically it's not that the part is printed and you directly take it. Basically there are certain steps that has to be followed in all these different process. So once it is cooled, basically there is something called as support structure. Basically when I'm saying subtractive manufacturing and additive manufacturing, the difference is in additive manufacturing, if I'm printing my structure in this manner, so basically there is no medium over here. So it is called as a support structure. It'll start printing from the first layer itself until come till here, and this will be my actual part. So after the complete printing is done, I remove the support structure. Basically the density will be lesser, so it is easier to remove. This it is when it comes to plastic, but when it comes to resin, you have to cure it under a UV resin. It is called as a UV chamber. You keep the part inside the chamber a little bit for 5 to 10 minutes, and then take it and then remove the supports. So this is SLA. So I'll take you, so also the difference between these three technologies also is the resolution, as in the quality that you get. So what you get in FDM is different from what you can achieve in SLA and SLS. As I told you, that industry is totally different. So I'll show you the working of an SLA, you'll get an idea.
The Form 1 Plus is a stereolithography 3D printer. Today, we're going to take a look at how it works and put it to the test against parts from an extrusion-based machine. Let's start by taking a closer look at the printer. When we open up the light-blocking cover, we can see a build platform inside. This metal plate is where the parts are made. Underneath the build platform is a resin tank. This clear window gives the ultraviolet laser a path to cure the resin. To start a print, we'll upload a file and fill up the resin tank to the indicator line. You can see the laser passing back and forth inside, hardening the liquid plastic. We'll take our printout and wash it in rubbing alcohol to get the excess resin off. The flower comes with supports on it, and we'll snip them off to finish the piece. Stereolithography is known for producing extreme detail with layers down to 4 times finer than a human hair. The Form 1 Plus lets us take advantage of a library of materials, so we made some other parts to show what these resins can do. A castable resin gives jewelers and engineers an inexpensive way to produce metal parts. This flexible resin is great for simulating different textures, and as we can see, this tough resin can really take a hit. Now let's compare how the Form 1 Plus parts stand up against a filament printer. The stereolithography part comes out nice and smooth, but we can see and feel the ridges on the cup printed with filament. When we break this sample piece, You can see that filament parts quickly snap along the layer lines. The SLA process creates a chemical bond, so our prints take much more force. Today, we took a look at how stereolithography printers work, the types of resins they can print with, and what makes the parts stand out against other desktop machines. If you liked our intro to stereolithography,
Okay, so that was the SLA process. So currently, the application for this particular technology will be jewelry. So why jewelry? So when I'm talking about things like a small earring or even a small part where people are expecting the resolution for about 5 microns or 10 microns. So this cannot be achieved in a normal FDM printer. A normal FDM printer, you can go up to 100 microns or maybe 150 microns. But since this is a resin printer, and there's another advantage also, since it's a resin printer, you can get a best micron resolution of around 5 micron. And in the video you must have observed, he said that it is a castable resin. So the best part is it can be directly, once the design is approved, it can be directly sent to the molding. It is compatible to the molding thing, unlike the other technology products. Maybe the plastics cannot be done, certain tooling has to be required, either investment casting has to be done. But in this process, I can directly send it to the casting process. So next comes the powder bed, which is nothing but the SLS technology, selective laser sintering. Even in this, the laser is used, but instead of resin, in the reservoir, I keep powder, basically. It can be nylon powder or ABS powder, any kinds of powder. And this powder, it is also not the normal powder. Basically, the crystals sizes are predefined. So it is not that the random crystal sizes are kept in the vat and then the selective laser is done. No. These powders are also special. You get these materials from certain manufacturers only. Basically, I'll show you the video also. So the process goes same. There will be a reservoir where the powder is kept, there will be a laser, and there will be a recoater. So since it was liquid, the recoater was not required. So what is a recoater? Basically, in the powder, when one layer is sintered, the bed goes down. So there should be something which has to level the surface and put the next layer of powder. Okay, so that is what is called as a recoater. So when every layer is sintered, the recoater goes from left to right or from right to left to make sure that the next surface is ready to get sintered. And the advantage of this technology is you don't need a support structure because the unsintered surface in and around acts like a support structure. So I'll show you the video, you will get an idea about this. So this is the normal process, that is good. It has a laser, it has a scanner system, which is a single module basically. And that is the roller that I'm talking about. So every time the piston goes down, the roller moves from left to right or from right to left and makes the surface even so that the next layer is evenly sintered.
Powdered nylon 11, nylon 12. Parts produced are lightweight, highly durable, and both keep expensive tooling. The SLS process begins by splitting 3D CAD data into thin cross-sections or layers. The data is then transferred to the SLS Additive Manufacturing equipment. The machine then begins to create the first layer. After a leveling roller spreads a thin layer of powdered material across the powder bed, a CO2 laser traces the cross-section on the material. As the laser scans the surface, material is heated and fused together. Once a single layer is complete, the powder bed is lowered to make room for the next layer. More material is introduced from the powder cartridge and rolled out smooth, while unused material is recycled. The process is repeated, building layer upon layer until the part is complete. As SLS parts are built, they are encompassed by unsintered powder, which provides supplemental strength and eliminates the need for support structures. Complex designs and assemblies, once thought impossible, are now being redesigned with SLS as cost-effective integrated structures. Solid Concepts manufactures parts utilizing nylon with property-enhancing fillers to create rugged SLS parts suitable for a variety of prototype and production applications. Typical uses for SLS include tools and fixtures, fuel tanks, flight-rated components for unmanned aerial vehicles, automotive designs, air ducts, architectural models, and artistic sculptures.
Okay, so that was SLS and SLA. I think you got the difference between the SLS, SLA and SLS. Now we'll come to DMLS, the very hotshot technology currently which is running, which it is called as direct metal laser sintering. So using DMLS, any end-used metal parts can be produced, not plastic, end-used metal parts. So so what you saw in SLS was plastic powders. In DMLS, we use metal powders. So that's the difference between the raw materials. So talking about materials in DMLS, currently there is nickel, there is cobalt, there is titanium, there is combination of all these materials. And materials are coming. Basically, the research is going on, the more materials are coming to the market. But still, this is in use right now, and DMLS currently is being used in the industries like aerospace, automotive, and certain research industries. So what happens in DMLS is again the same thing that you saw in SLS, but there are certain things that has to be maintained in DMLS, because here we are talking about not the 100 watt or a 60 watt laser. Here it will be a 200 watt laser, which is a very high power, and it is the chamber is maintained with argon gas. And okay, so the carbon dioxide layer is fired into a magnesium substrate. So just imagine, a laser firing into a bed full of metal materials like titanium material, and layer by layer the thing is basically the 3D printing goes on. So here the material dispensing is also different. The ambient temperature has to be maintained. There has to be certain things which has to be taken care over here. Basically the support structure cannot be removed using any cutting plier or normally manually by hand. This needs proper machining process. Because again we are talking about metal over here, so we cannot remove it manually. And even the slicing process for DMLS is totally different, because the powders are very costly, and the machines also that are currently available in the market starts from 2.5 CR. So any part, so currently in India only defense industries are going for this technology, because I think any other small SMEs cannot afford for a DMLS process. The best part about this is what your conventional method cannot do is 3D printing or DMLS process can print any geometry, any complex geometry, which you cannot do with a conventional method. Basically, even an impeller too. So I'll give you the rate, basically the price difference that happens in this. So to print an impeller of 42 cm dia, it costs 2.5 lakhs. Which if you go with the normal conventional process, it is 3 times or 4 times lesser than that. But again, this is created in one shot, and you don't need any further post-processing in this. And so the difference in slicing this a model for DMLS and other processes, here you have to be very careful about the orientation of the model, because if you miss in any parameters, you will lose a lot of money and time, and also because the raw material that goes inside will cost somewhere around 30,000 to 50,000 or even more than that for a kg or even 500 grams of material. So that is really very costly. So currently this process is really very expensive. So only certain industries are going for it. But companies like GE and Siemens have been successfully integrated a lab inside where they have done their own machines. They are researching on their own machines. Basically, they are researching on materials over there, so that how the cost can be reduced and how the quality can be improved over this. I'll show you the working of DMLS.
Creates strong, durable parts and prototypes. DMLS is an excellent choice for functional metal prototypes, high-temperature applications, and end-use parts. The DMLS process begins in the same fashion as other layer additive manufacturing technologies. A program takes 3D CAD data and mathematically slices it into 2D cross-sections. Each of these sections will act as a blueprint, telling the DMLS machine exactly where to sinter the metal material. The data is then transferred to the DMLS equipment. A recoater assembly pushes powdered metal material from the powder supply to create a uniform layer over the base plate. A laser then draws a 2D cross-section on the surface of the build material, heating and fusing the material. Once a single layer is complete, the base plate is lowered just enough to make room for the next layer. More material is raised from the cartridge and recoated evenly upon the previously sintered layer. The DMLS machine continues to sinter layer upon layer, building from the bottom up. As the part is built, support structures are added to give supplemental strength to fine features and overhanging surfaces. The completed part is then removed from the base plate and treated with an age-hardening heat process to further harden the part. Any support structures are also removed at this time. With numerous surface treatment and hand polishing options available through service providers such as Solid Concepts, DMLS parts can be used in highly cosmetic applications. Typical uses for DMLS include tools and manufacturing aids, small integrated structures, dental components, surgical implants, and aerospace parts.
Okay, so that was DMLS. So currently the demand for DMLS is increasing day by day because the compatibility of materials is also increasing. Every day you can see some or other new material is introduced into the market. Okay, coming down to the extrusion 3D printing, which is currently seen everywhere, and you can see, I think it's there in your college also. This is basically the FDM 3D printer where a plastic is fused and basically a layer by layer the model is created. So that is the process in this. I'll show you the working.
Fused deposition modeling, or FDM, is a layer additive manufacturing process that uses production-grade thermoplastic materials to produce both prototype and end-use parts. This technology is known to accurately produce feature details and has an excellent strength-to-weight ratio. FDM is ideal for concept models, functional prototypes, manufacturing aids, and low-volume end-use parts. The FDM process begins by slicing 3D CAD data into layers. The data is then transferred to a machine, which constructs the part layer by layer upon a build platform.
Okay, so that was FDM 3D printing, so you got the difference between all these processes. So these are all the major processes under additive manufacturing. We started with SLA, we came down to SLS, then we went to DMLS, and then I was showing you the FDM. So the basic difference between this is the materials that is being used. The tool head which will basically act as a source, and the post-processing and the pre-processing that is involved in the process. But the basic mechanism for all these technology remains the same, which is again additive manufacturing, or we can call it as a 3D printing. After this, I'll take you to the applications of 3D printing. I have included some of the use cases of our own, where we have seen the live application of this particular technology with our clients. We have experienced it with our clients. Other than that, will also see about how it is being used in aerospace and even automotive industry. Yeah. So we'll start with the medical industry. So currently a lot of doctors are researching on this. It is not a foolproof concept for this particular industry till date, but the scientists and the researchers are sure that in the coming days, this particular technology will help them a lot. So when I was talking about bio 3D printing, that was the organ 3D printing. So currently I'll tell you, I have got some statistics from Indian Medical Association. So currently we need around 250,000 implants, transplants of kidney, around 50,000 transplants of liver, and also around 25,000 of heart. What we currently have is in around 1,500 for kidney, 50 for heart, and around 3 digits and for liver. So just imagine if this particular technology comes through, then it'll be a game-changing thing. It'll be another revolution over here. So currently in the medical industry, what is being used over here is basically before any major surgery happens, there will be a demo surgery. Any surgery which goes for 16 hours or which goes for a very long time, they do a demo surgery. So we have a live, I have a live example for this. So I was dealing with this hospital called 3K Healthcare, where a patient had a damage in the skull. So basically the doctors approached us and they asked us to print this particular skull, and we printed it. So basically it's not that the file that I received was a DICOM image. So a DICOM image is a 3D ultrasound file which is given by the doctor. And so that particular file is converted into a printable format by using certain softwares, certain slicing softwares, and then we print it. So basically you get to know that where exactly is the damage, what exactly is going on internally. So basically the group of doctors conduct a demo surgery, and finally, so the surgery which was about to take 16 hours, it will get reduced to maybe 8 to 9 hours. So this was the input again from the doctors. So I mean, we are no one to make final evaluation or conclusion in this. This was the report given to us by them, and we were really happy that something like this is happening in this. Other than that, you can see it is being used in the dental industry currently, where I told you initially about the PEEK printer. Polyether ether ketone. So yeah, they are trying to replace titanium with PEEK, but again it is not foolproof as I told you right now, but yeah, things are going on right now. So coming to the next industry, it's automotive. So it's very simple. So what happens in all these automotive industries is, so we have Toyota Kirloskar and Mercedes-Benz as our client. So what these people do is, so before any new part, before any new functional part is injection molded or mass manufactured, it is in the development stage, basically the product design and then prototype. So what happens in this stage, it is not that I designed a part and it is accepted in the first shot. There will be a lot of changes. So what used to happen before is, they used to do it using a different process. It was very manual. They used to use MDF sheets, acrylic and different materials. But after 3D printing, so what happens is once the design is done, they 3D print it, they do the due diligence, and so in any part, in any automotive industry, a single part undergoes around 5 to 7 iterations. So 5 to 7, after the 7th iteration, the part is finally accepted and it is sent into the next department where the final thing is done, and it is sent to the mass manufacturing. So automotive industries use it like this. Any engines or any new parts that has to be basically in the research stage, this technology comes to picture. Coming to the architecture, okay, architecture is also a very big industry currently. How it is being used is basically again the prototype thing. We have a lot of architecture clients also. So what they do is instead of building the models by using thermocols or any other wood or any carpentry, here it can be developed using a multicolor 3D printer. So when I say multicolor 3D printer, it's actually a multicolor, and it uses around 32 different colors of your choice. It is called as the polyjet mechanism. Again, it is the same thing what I explained you in the process. The only difference is the raw material. The input that we are giving is the inkjet mechanism. So in the architecture field, I can show the overview, I can show the side view, and I can show the internal parts, what exactly is going to happen after the building stage, before the possession. So in the education industry, it is currently the best industry, what I feel, because we have a lot of educational institute as our clients. Now, what happens in educational institutes? Very simple. In engineering, there's for mechanical students, there is a subject called as rapid prototyping. So it is very useful for them in that. And other than that, for any engineering student, when they come to their 7th or 8th semester, they do a project, a mini project or a main project or something. So you must have seen or you must have experienced it, that you approach to different vendors. If you are an electronic student and if you have developed a board, or if you have done a project using Arduino, then for the outer casing, or to protect it from getting short, or protect it from other factors, you go to different vendors and ask them to do a box for this. Now it's very difficult for you because they won't do a single piece for you guys, because all these guys are into mass manufacturing. So talking about that, 3D printing actually helps them a lot. You just design it and you can print it and you can actually use it. So other than that, it is being used in a lot of research institutes, IIT Kharagpur, IIT Delhi. So IIT Delhi was the first college which successfully printed the cartilage, which was never done in the world, and it was actually molecularly it matched to the knee molecules, knee cartilage, the kneecap cartilage. So that was the best breakthrough that was done in the bioprinting industry over there. So yeah, in education there are a lot of so currently all the colleges are coming up with the education, the 3D printing labs, where there will be printers, there will be scanners, there will be different type of materials. So whenever you need anything, you can just go and print it. Coming to next, it's the defense. Okay, I've shown a very wrong picture, but why I've shown that picture is people have actually printed an operational gun, and it is actually illegal right now, but this has been printed, and that's why people also rumored about that this technology shouldn't be promoted because illegal items like these are being printed. So, but in the defense, the actual use is being done by Lockheed Martin in US, and also the Drupa, the actual US research group. So how they are doing this is basically they are printing the external faces, basically the shield or the external boxes or external the packaging stuff for the defense thing, which cannot be done with the normal material. Here they are researching with different kinds of plastics. That comes to defense and manufacturing and small scale industries. Now this is the biggest industry for us to tap, for any 3D printing company to tap. There are around 50 million SMEs in India. So everyone needs either 3D printing or 3D printing service. So that's when it gets to picture. You go to any manufacturing, 3D printing manufacturing company, you check their clientele list, you'll find most of SMEs in their list. There's a reason behind it, because prototyping is something which is mandatory for them. Now, talking about aerospace, so aerospace is something which uses high-grade plastics. We are not talking about normal PLA, normal ABS, or normal plastics which you get for 1500 rupees. So in aerospace, a technology like FDM cannot be used because it's not feasible. In aerospace, a technology has to be used which can be the parts which can be functional and which can be used. So GE were successful to print, the fuel nozzles and the intake manifolds and different parts, and which has been end used in this particular industry. Gifting is a sector which is very very normal, and anyone can start a business using a 3D printer. Basically, gifting, you have to gift someone and you have to write your name, and you have to attach your photo. You can do it with a 3D printer. Keychains, pen stands, business card holders, etc., etc. So to get all these files, you can check this website called as thingivers.com. It is called as Thingiverse, THINGIVERSE. So there are more than 2 crore ready-made STL files. You can just download the STL file and print it directly. So files like Narendra Modi, Eiffel Tower, Taj Mahal, and all these monuments, different categories are there. You can explore it. Then it comes to fashion. So this industry has not been explored much till date. So that was the shoe that we printed for a shoe manufacturing company. So they were researching with it was in the development stage. So that is the flexible material. It's a flexible plastic. It's called as polyurethane, TPU. And this can be printed using a normal FDM printer. Other than that, in the Lakme Fashion Week, people tried printing different attires and walking the ramp, but it wasn't so successful. So used cases that we used, so it is the eye testing machine. Praman Mini is one of our printers that we have. The material used was ABS. So printed by Lil Shapes Bangalore, that's one of our clients. So I'll tell you why I've shown this as a use case. So this particular machine was sold for around 1.5 lakh, and I'll tell you the investment that went for this. So as you see, this is not a single printed part. It is printed separately. The parts are printed separately using 3 printers, and around 4 kgs of filaments was used. So the overall investment that came to print this is 8,000 rupees. 8,000 rupees, yeah. So this particular guy who buys this particular eye testing machine orders a minimum of 3 to 4 machines every quarter. So before, he used to spend around 2.5 lakhs or maybe more, and he was not sure about the customization. So here, actually, the customization is done according to the, basically, you have seen an eye testing machine. What you do is you basically keep your chin over there, and then the process is taken forward. So you can see the profit margin that the client is making because of this. And the material was also compatible for this, because this wasn't exposed to fire or any other things, any other factors. Okay, so coming to the gifting industry, so what you see over there is something called as lithophane. So you can normally, you can basically download any normal JPEG image. You can get it into the software, and it will get you printed. Now the best part is the photo is not 3D printed, as in the photo is a normal JPEG image, 2D image, but it is printed in such a way that when you expose it to light, and it is extruded maybe a minimum of 3 mm. So when you expose it to light, you can actually see the actual JPEG image over there. And then people do it with a frame, put a normal mercury light, and it looks really well. Other than that, iPhone cases or any phone cases, and these are all the normal stuff that was done in the gifting industry. Now, this is a very good, this is basically a Raspberry Pi, and this is also a student project, basically. This design was done by us with all the customization that the student required, and it came out so well, and the fittings, basically, the clearances and the tolerances was matching so well. So this was when we initially started the company. So these are some of the use cases that we show in the electronic industry. So if there is any customized board in the market, And obviously the board has to be covered, either you're using it in a machine or in any variable devices, the electronics has to be covered. So 3D printing comes to the picture in that manner. Okay, so these are the seat belt parts. So this parts was printed in our printers, and this is tested by a company called as Autoliv. Autoliv is a company which manufactures seat belts and all these minute indoor products in a car. Now, basically, that is all these are printed in ABS and post-processing done. I'll tell you about the post-processing later. So basically, the bolts and basically the fittings and everything is checked using this. So this is basically the testing part. Once it is printed, each and every bolts, nut bolts, and all the fixtures are tested using these parts. Then we have a wind deflector. This was actually the 750 in width. This was printed in the 1 meter printer, the Praman one. This is a seat belt tongue assembly testing fixture, again by Autoliv. That is the STL, that is the design, and this is the actual printed part. All these parts are printed by using the material ABS. Flexible, this is again the TPU material that we have. Okay, this is something which the CNC machining was not able to do, and which was done in the FDM printer, and finally they fixed their all the other parts, and it was finally tested with this was also printed in Praman 1. The photo looks very small, but it is actually more than 500 in height. This is a very interesting test case. So there is this cantonment in Indore, Mahou cantonment. They are opening a museum where all the martyrs will be displayed in the actual format. It is like a Madame Tussauds for Indian Army. And like you see, that model is being printed. It's actually 3D printed, but a lot of post-processing is done after that. There were 2 to 3 artists involved who are regularly painting it. This is the actual. This was printed separately. The head, the hand, the body parts were printed separately. It was assembled together. And similarly, this is just one model. You can see around 32 to 40 different models that is currently being printed and which is installed over there. So if you're visiting Indore anytime, please visit Mahou cantonment and you can see this. And this is completely out of an FDM 3D printer, not any other process. What you see here is a terracotta clay. It is a terracotta clay. Now, this is a problem that we solved in a small cluster in Andhra Pradesh. So what happens is, there's a village which has around 1,200 artisans. So their livelihood is, so what they know is only to make models out of terracotta. So you might have seen in places like, different beaches, you could see these models, very well painted, and, you really get attracted to these models. These are actually made by these artisans. Now the problem that they were facing is they used to make all these models manually. As in, they used to make the hand molding and stuff. Now the disadvantage was they couldn't do whatever they thought. Basically, if I'm thinking I have to print an Iron Man, make a model of Iron Man, I cannot do it because it's very complicated. So that's when we introduced this particular technology. So what 3D printer is doing over here is a very simple thing. It is only creating a master mold. So suppose I have an idea of, getting 2,000 terracotta models of, say, Spider-Man or any, this DC Marvel character. Then I'll just design it in a 3D model. I'll 3D print it. And after 3D printing, I'll take the POP cast of it. And after the POP cast is taken, it is heated, and then the mold is created. Inside the mold, you put the POP, and finally I take the POP mold. And out of the POP mold, I introduce the terracotta clay, and so the process is continued. So here it was a very good thing. This is one of the very good use case till date that we are doing. So we are actually solving. So the difference is what before they used to create only 200 designs. That too very normal designs. Even when it comes to Ganapati, it used to take them around 2 to 3 weeks just to make the master mold. So here, the single Ganpati or even any models is being created within hours. And instead of 200, we are talking about 2,000 different designs. So, so the overall, the difference that the technology is bringing over here is even in the revenue, where they used to earn only 10 to 15,000 per month. Now I think they can double it by using this particular thing. Okay, so this is a normal. Ford produces 12 cars a minute by being heavily dependent on AM. So Ford was the first automotive company to introduce this technology. They were the first ones to print intake manifolds and test it in their cars. Finally, today, Ford is in such a position that they own a lab which consists of around 150 printers of different technologies. And yeah, it is being, so this technology is introduced from the prototype stage to the product development. So the advantages of FFF, I'll tell you, FFF is the FDM process. Compared to other processes it is inexpensive. The machines that used to cost around 4 lakhs, 10 lakhs before, okay, I'm talking about the prices that were 4 years back. Today, you will, if you go to eBay, if you go to Alibaba, you will get a printer for 7,000 to 10,000 rupees also. So it is inexpensive in that way. The material, which used to cost around 3,000 to 5,000 rupees per kg per spool before, now you get it around 800 to 1,000 rupees per spool. And it is very easy. The process is very easy. A normal layman can easily understand the process and can easily. Today, the printers have been advanced in such a way that you don't need a computer to operate a 3D printer. It's a standalone system. You just need to slice the file and then start printing. It's a 3-step process basically. And so the best part in this process is the internal structure can be controlled. So when I was talking about the infill, the internal structure, if I want to print this particular part in zero infill, which means it will only create the perimeters. That means the printing time is less, the amount of material taken is also less, which cannot be done in any other process because that option is not feasible with it. So here if I give 100% infill, if I want something to be very strong, say if I'm printing a gear and I'm testing it as an end-used part, then I cannot print it with a zero infill because it will easily break. So that is the thing. So talking about post-processing, so that is a very crude model that you get out of a FDM printer. As in, right after the printing, that is what you get. It has been printed in 300 microns. The best micron that you can get in an FDM printer is 50 to 75 microns. Now, how do we get this? This is somewhat which is acceptable by the people, by the industry, by anyone. Basically, the aesthetics should be fine. So the process goes like, so there are a lot of post-processing methods. There are manual methods like where you can use different grades of sandpaper and just keep rubbing. But again, it takes a lot of time. There is something called as acetone bath. So acetone bath follows like, so if you have printed that particular part was printed in ABS. Acetone only reacts with ABS, not with PLA or nylon or any other plastics. So what happens is you print the part, after the printing you keep it on a heated bed and you maintain a temperature of 100 to 110 degrees Celsius. You pour the vapor, you pour droplets of acetone around it. For this particular part, it is like 6 centimeter in height. You keep it for like 2 to 3 minutes and the vapors basically eliminate the lines. So again, you have to be very careful that if I leave it more than 5 minutes, it will just vaporize. So I should check the time also. So in 4 minutes, if I have to monitor it continuously. So basically the vapors eliminate those lines. So basically since it is created layer by layer, that is a 300 micron line that I am seeing over there. It doesn't look good, right? So basically what happens is the vapors eliminate those lines and finally you get a glossy finish like this. There are a lot of post-processing machines currently available where you can get matte finish and glossy finish. This goes with this particular technology, like the FDM process. If we talk about SLA and SLS, we don't need we need the cleaning of the part, but not the post-processing, as in not to entirely change the aesthetics. So yeah, advantages of 3D printing is vast. It is very huge. It is very wide. Basically, this technology changed the concept modeling and the prototype definition. Currently, wherever there's a major prototyping happening, you will definitely see a 3D printer over there. So these are the machines that is done by us. This is the smaller, this is the Praman 200. Praman is our basically our machine name. Praman means proof, and Hindi basically which relates to prototype. This is the 200 machine, the 300 machine. 200, 300 is basically the build volume. That's the difference. And these are all the standalone machines. You don't need any system to operate these machines. Then we have industrial grade printers. This is the 500 mm. That's the 750 mm one. Basically, all these printers have air filters, and the temperature is maintained within the printer. Or else you can see, if anyone has used a 3D printer, you might have faced the problem of warping, basically warping of material. So if the material is warped, basically if the first layer doesn't stick to the bed, then it basically warps. So that model is waste. So to counter that part, we have completely enclosed the machine, and as you can see, the temperature is maintained within that. So these are two of the USPs of our printers. Praman HT means Praman high temperature, which can print high temperature parts. It can go up to 450 degrees Celsius. You can print carbon fiber, any composites, any metal composites, and the peak can be printed in this particular printer. It has a certain different chambers which maintain the temperature over there, and that's the largest printer that we have, and also one of the companies right now which manufactures the 1 meter printer in India. So yeah, that's all for the overview of 3D printing, not getting into the depth. And so if you have any queries or anything, if you want to see 3D printers live in action, you can drop down to our office. We are located out of Kukatpally, and if you are in Bangalore, you can come to our office in JP Nagar. You can see printers in action. Also, if you have any queries, you can come to us, we can chat to you. Yeah. So any questions on this? Yeah. Okay. Any questions? Yeah. So the printing machines, ma'am, the smaller ones, the desktop printers will weigh anywhere between 15 to 30 kgs. And the industrial grade printers can go up to 250. Whereas the CNC machines has to be a single setup where once you keep it, basically you cannot move it. The desktop printers can be, it is portable, you can take it anywhere. And the industrial printers can also be moved. But the weight compared to CNC machines is pretty less. Yeah.
Hi, this is Satish.
Hello, sir.
It's a pretty informative part that you have explained. So I'm coming pretty much from the student background kind of scenario. Question is, I saw you got into different kind of technologies and the printing part. The question that goes around is it an R&D that you are into, or you are procuring the equipment, and how is that particular part? From a student point of view, easy need to understand the design part of it because there's an electronics that is involved, right? So if you look at the kind of an audience that are in here, so where do you want them to put their kind of thoughts into? The technology with respect to 2D, 3D, fine.
Yeah.
But in Indian kind of context, when there's good scope with defense and other things coming into picture, where do you want a student to start thinking in? Is it in the electronics part, the design part, or where do you, because you get a lot of experience, some thoughts.
Thank you, sir. Thank you for the question. The students, basically, talking about electronics, it is a part of the printer, and it has already been, as I told you, it is an open source platform. The electronics, the mechanical parts, and all the things are already given. What students needs to focus is basically where this particular technology can be, what kind of designs can be taken out of a 3D printer. When we talk about customization, so it is everything that we ideate, what we think has to be printed over there. So they need to think from a design prospect. That is very important. Electronics, I think, so I am an electronics engineer, so when I have taught more than 25 groups of students for their final year projects. It is, the electronics is very easy to grasp. It is basically a Arduino based program. The Marlin, basically we call the code as a Marlin. It's a C platform Marlin. It's already written. So once we understand the configuration part, which is again very easy, it's again very easy for an engineering student to grasp the electronics part. Coming to the mechanical thing is also easy. But what I think the students should think is from a design point of view. It should be completely the design point of view. There are a lot of students also, sir, who designed their own machines. Basically, the mechanism was the same, but you know, they got a difference in the X and Y axis. Basically, they combined X and Y axis, or they made Z axis stationary and they made the overall XY gantry to move up and down. So these were all some of the changes, basically the mechanism changes that some of the students have done. So even over there, it is not the electronics or the mechanical that is involved. It is the complete design thought which is going in. Yeah, thank you. Hello,
it
sir.
was good presentation. Thanks
Hello.
for this.
Hello, sir.
I have only two comments. You mentioned that the medical, the 3D printing in medical is a research field,
Yeah.
but actually that is also crossed.
Yeah.
There are machines available, there are software available for 3D printing of metals in the medical this thing. In fact, there is a company in Belgium called Materialize. They make machines.
Yeah.
And I think recently, some time back, I saw this thing. They were making the kneecap for the Queen of England. Yeah, I think they must be. So the technology, what I wanted to tell to the audience is the technology is changing so fast. Whatever we think is the future, that is already happening in the past.
Okay.
That is the way the world is moving. So now he mentioned about the 3D CAD model and take that as an input and create that. Now you have a surgery of your kneecap or your hip bone or even bone, whatever, you know. There is a CT scan which really scans and it gives a cloud of points from which you can take the data and create a 3D CAD model. This can just happen in the click of button which he will recognize. Yeah. And the moment this 3D CAD model is available, this can be imported or exported anywhere to any platform and it can be exported to these machines. So in a way, the patient can be somewhere in Bangladesh, it can be taking a CT scan, the 3D CAD model can be cleaned up, for example, in Bangalore or Hyderabad, then the printing can happen in Belgium and then the thing can go directly to the Bangladesh person. This is the way they say that is happening and this is already the reality.
Yeah.
The second thing coming to you, I think you were asking a question whether it is mechanical or electronics. And this is, the branching system is not really good. It's a old concept. Earlier, there were only two branches of engineering. Can anybody tell what is that? Civil and? How come civil and mechanical? Why not electrical? No. I am asking question. Why civil and mechanical? That is my question. Earlier I said there were only two branches of engineering. Okay? Then somebody said civil, that is correct. But then it is not mechanical. Why mechanical? My question is why you call civil and mechanical? Why not civil and electrical? Earlier there were only two branches. One was civil engineering and the other was military engineering. So later it got into other branches. So the conditions for military engineering were different, etc. So what I am telling is today, whether you take a 3D printing system or any system, it is not just any one branch of engineering. It is all the branches. There is a material, there is design, there is manufacturing, there is electrical engineering, there is electronics, controls. Everything is involved in all the branches. So that way of looking at it is not the right way. It is engineering, okay, some specialization. But then you have to realize a product and that product has to be delivered. He is talking of medical implants. what patient needs is a implant which suits his knee or his hip, whatever. And that's all. How do you deliver that to him? Whatever engineering you have to adapt, you have to adapt. That is the way it should be looked at. So from your point of view, okay, there is a mechanical engineering aspect or electronics engineering aspect in everything. Okay, that's all I wanted to make. Thank you.
Thanks a lot, sir. Thanks. Also to add upon you, sir, as you said, the machines are available. You are right. I just remembered there is a company in Bangalore also. It's called as Pandora Technologies. You might have heard. They have also created a machine where they have successfully got the liver tissue output. So they were the first company in India to get this liver tissue bioprinted. And also there's another company, Next Big Innovations. These two are the companies in India which are funded by DST, and they are actually developing the bioprinter. So thank you, sir. Thank you on that. Yeah, any other questions?
Hello, sir. Sir, I would just like to ask you that rapid prototyping is used only for less number of products, but the traditional way we can do mass products. So there's a great disadvantage for the additive manufacturing. So.
Yeah, you are right. There is a disadvantage for this. As you said, it can be used in the prototyping stage and for slow volume productions. And it is currently, I wouldn't even market the technology. It is not in a stage, and I don't think it will be in a stage where it can do mass production. It is called rapid prototyping machine for a reason, and there are some constraints which maybe it will be overcome in future, like the speed. No, why it cannot mass manufacture is a simple reason. To print a normal 25 cube, it takes half an hour. Okay. So what you can do over there is, if you have the die with you, you can create multiples of that. So it is not even closer to mass production. So here we are talking about low volume production and the prototype. So yeah, there is a full stop on that till date. But yeah, it is not equivalent to mass production in today's date. No.
Thank you.
Thank you.
One last query I have.
Please, ma'am.
Is there any language or programming language that we need to know to basically program our
No,
3D?
not necessary, ma'am. So if you know CAD design, that is more than enough. Even if you don't know a CAD design, if you have a design with you, you can directly print it. It's a 3-step process. Slicing of a software is where you just input the settings, basically on what resolution you want the print to be, what infill you want the print to be, at what speed you want the print to run, and what kind of support structures you need to give. So these are all like 1 day or 2 day training that can be given to anyone, and you don't need any programming part for this. It is just a combination of design and then the printing part. That's it. And as I told you about the website Thingiverse, you have every day there are around 1,000 STLs being uploaded by different freelancer designers around the world. So you can download it and directly print it. It's a ready-made STL file. Thank you.
Thank you. I think Manish, you stand as an example, wherein you have just come out of college and you started off with this initiative.
Yeah.
Can you actually give any inputs to the students here? That is, if they have an idea of they being an entrepreneur or they're starting their own idea in their terms, can you give some inputs to them?
Thank you, ma'am. So talking about this, sir was saying it is not only about the theory knowledge that you give. I'm a victim of that, so let me explain you. I'm a very average student, but sir gave a very right point about the basics. The basics has to be very strong. So coming from an electronics background, I had to learn about the designing part. I had to brush up basically, because there was one point of time where we had to get serious because our company had to run. We didn't have any other option, and we had a very limited source of 6 people. And Bangalore was a very unknown place to us, and somehow we managed. So talking about the starting up, Basically, it is very important for the basics to be very strong. Trust me on that part. It can be, mechanical or mechatronics. It doesn't matter what background you are coming from. But as sir said, the engineering basics. So if there is anything in front of you, I'm talking about the technology part. If there's anything in front of you, you should get an idea like what's going on. So basically, an entrepreneur. Today, I don't call myself as an entrepreneur, but still. So a difference between an entrepreneur is, so slowly, initially, I didn't know what it is. When we started, there was no mentorship, there was nothing. But in today's date, people like sir, there are a lot of our mentors who actually, show us the right path. So it is very required to, get the proper guidance and opt the right path. So you might have heard about this thing that 99% of startups fail or 90% of startups fail. That's fine. But, if you think, yeah, there will be a point where you will be totally, there will be a lot of ups and downs. There will be a time where you'll think, okay, fine, let's shut down the company. It's not happening. I'll go tomorrow. But these are all the tough times. If you definitely overcome it, I think, you'll reach a point. I mean, there are a lot of examples in front of us. I mean, whenever we talk about entrepreneurship, we always say Steve Jobs, we always say Bill Gates and stuff. But yeah, there are a lot of examples nearby also. We talk about Flipkart, we talk about Paytm, a lot of examples. So there was no story which was very easy. There was no person, there was no entrepreneur who has, directly come out of college and, got investment or got success. So I know the pain behind getting the investment and, running behind the investors. It's not so easy again, definitely it's not so easy. So it's a step-by-step process. So basically, recently we were in IIM Ahmedabad. There was a program from Economic Times Power of Ideas. So all the IIM professors were guiding us to how to run the company basically. So there was a very, very great knowledge that was taught to us. It's that you don't remain a company after a certain point of time. You are managers for only certain point of time. So, okay, fine, you have started the company and maybe after 5 years down the line, 10 years down the line, the process has to be set in such a way that you are independent of company. No matter even if the investment is coming or not, even if the company is bootstrapped, but if the team is strong, if you have a right team, if the process is set, the managers has to be changed. If you see Steve Jobs was also fired, if you see the movie, he was also fired in between. So basically the process has to be set basically. So I'm following the same thing right now and I think that's the right way to go forward. After a certain point of time, you cannot do everything. You cannot do the production, you cannot be a part of R&D and you cannot do sales. So today I'm totally dedicated to one particular field and I'm just following it. And I'll make sure that, 3 years, 4 years down the line, there'll be a guy, there'll be a subordinate of mine who'll be equally talented, who'll be equally skilled, who can sell products or who can make products like me. And that's the day when, I'll be just sitting at home and I'll be just waiting for the money to come in. So, yeah, thank you.
We are really thankful, Manish, that you set us as an example to our. This is one of the important factors that when we were actually going through whom to talk and whom to pull for this topic, we found them as a right example. Thank you very much for coming here and on a short notice and giving us a very delightful insight. And I think even the presentation, do you agree with me that I think the presentation also was very good, which was keeping us alive, not sleep with a lot of videos. So thank you very much, Manish. Here a small token from Ramakrishna and myself. Now we have our lunch break, okay? And it is for 45 minutes. and we shall gather here by 2:15. So please make a note. Already we are running late, but we shall try to gather here by 2:30. Okay. Please be back by 2:30. Thank you. Lunch is served outside.